Hey guys, I'm going to do a couple of the problems from these notes, the 4.7 systems of linear inequalities on the whiteboard. So basically what you're doing is you're graphing, as you can see in the picture, you're graphing two inequalities on one graph, and you're shading the region where they would both be shaded. Basically your solution set is, like if you look at this one, you have a dashed line. I know you can't see that well here, but with the pictures and your own notes, you'll be able to see. This one's a dashed line, and it's shaded above, and that's all this shading up here. And this other line you can see, it's solid, and it's shaded below. So between shading above one line and below the other line, this overlap region where they both get shaded is actually the solution set. So that's what I'm going to do with the first couple. The first one, problem 1a. And as you can see from this, you don't necessarily need graph paper, but the first one says y is less than negative 3x plus 3. The other equation, y is greater than or equal to negative 1/2 x minus 2. So you got to graph both inequalities on one number line. You saw how to graph one inequality the other day where the symbol tells you whether the line's solid or dashed, right? So I know this one's a dashed line because it doesn't have the equal to, right? If it has equal to, we make it solid. If it, like this one, will be a solid line. And then also the symbol tells me where to shade. So this will be a dashed line. It says less than, so this one will be shaded below. And this one says greater than or equal to, so it'll be solid because equal to, but it'll be shaded above because it says greater than. So, and then all the other things apply, the b and the m, the begin and move, so you want to have y by itself. Okay, so begin 3 up plus 3, then the slope is negative 3, so down 3, right 1. Again, this will be a dashed line. So there's the first one, and obviously a straight edge would be nice, but either way, my first line dashed, slope is negative 3, y-intercept is 3. The second line, oh wait, this is what I like to do. Some people will shade both lines and then darken in where both lines get shaded, but for me, and when I'm graphing a system of inequalities, before I even shade, I'll just use arrows to kind of point where I should be shading. So this line says less than, meaning it should be shaded below the line. So instead of shading below, I'll use arrows to kind of remind me when I'm ready to shade, which is after the second line. So second line is begin at minus 2 from there, then the movement after that, right? Begin and move is negative 1/2, so down 1 and 2 to the right. Down 1, 2 to the right here. And so this line is solid, remember, because it has the or equal to 2. So use a different color here. So this line will be solid because it has the equal to, and it says greater than. This line says greater than, meaning shade above this line. So if I shade above this line, I only shade, again, I like to use arrows because then it comes out cleaner. I'm only going to shade where both lines are pointing, meaning the area or the region where both lines are pointing. It's not here. Down here, only one line's pointing here. Nothing is pointing in here, right? You can kind of break your regions down to 4 regions. I'm just going to put some numbers in them actually to drive that point home. So there's, like, this is one of the regions. This is the other one. Here's a third one, and then here's a fourth region. And the region or the area where both lines should be shaded is where they're both pointing. It's actually the one that I put a 4 in. So I'm going to call this region 4 for now and advise you. This is the area where all the solutions lie, right? What we're shading basically is all the points that would be solutions for both inequalities. So that's this area. Any points that land on the dashed line are not solutions. Any points that land on the solid line are solutions, right? The equal to, right? The solutions can be equal to what's on this line, but the dashed line didn't have the equal to, so the points on the dashed line aren't solutions. So I'll post all the answers, but I'm going to skip around just for the video. So D, problem D has something a little different. It's just y is greater than 1, right? It's not in the full-blown y mx plus b format. And the second line, y is greater than negative 3 halves x minus 2. Again, that's problem D. So same thing, what I'll do is I'll graph both lines. I'll use arrows to show me where to shade, and then I'll shade at the end. At the end, once I see where the region where both lines are pointing to, that'll be my solution set. So first line, y is greater than 1, all I gotta do is put a 1 on the y-axis. It's gonna be a dashed line because it doesn't have the equal to, so it'll be a dashed line, actually a horizontal line, where y is 1. And it says greater than, so that would be shading above the line. The second line, begin and move. So begin at negative 2, that's down 2, because it's negative. And then your slope is negative 3 over 2, which means go down 3, right 2. So down 3, right 2, from the beginning point, right? So down 3, right 2. This is a greater than symbol. It doesn't have the equal to, so another dashed line on this one. As you write on your paper, a straight edge would be nice, but do your best, straight edge or not, do your best to draw the line again. This one doesn't have the equal to, so it's still dashed or broken if you like. But it does say greater than, which means shade above this line. And so again, like I said, I like to use arrows to show me where to shade. That way at the end I only shade the region where both lines have solutions. So if you look at all where the arrows are pointing, right, again, I can still break this down to like, here's one region, here's another one, and here's the fourth region, right? So which region has arrows pointing from both lines, right? And hopefully you're with me. The region that I should be shading here is not 1, there's no arrows there, not 2, there's only 1 arrow pointing here, not 4, only has 1 arrow. The region I should be shading is region 3. Arrows from both lines are pointing at 3. So you could shade both. You could shade both lines and then just darken in the region where they overlap. That is an option. I like this better though. I like just using the arrows to show me where to shade, and then shade at the end once I see the region where both lines should be shaded. So that would be there. And then just going to do one more of these from the notes. So I'm doing example F as the last one I'm going to show in the video. It gives me a chance to, well, not only show you one more of these, but also remind you sometimes you do have to get y by itself, right? I kind of want my equation in the form, or inequality that is, I want it in the form y equals mx plus b. So I want y by itself. So it gives me an opportunity to remind you, you have to get y by itself sometimes and how to do that. And also to show you when you get a vertical line, right? The last problem I did had a y by itself with just a number. It was a horizontal line. When you have x by itself with just a number, it's going to be a vertical line. So first, let's get y by itself. So we're gonna subtract 2x on both sides. So I get 3y is greater than or equal to negative 2x plus 6, and then I would divide by 3 on both sides. Every term gets divided by 3, and you get y is greater than or equal to negative 2/3 x plus 2, right? I'm ready to graph it. So Doesn't matter which one you graph first. If I graph this one first, begin and move, right? So begin is 2, that's plus 2, so begin of 2. The slope is negative 2/3, so down 2, right 3. Down 2, right 3. And it says greater than or equal to. Remember, or equal to is a solid line. So I can go ahead and make the line solid. Greater than or equal to, right? So the greater than part is telling me to shade above this line, and then this one, right? X is greater than negative 3. Well, all I gotta do is go to negative 3 on the x-axis. 1, 2, 3, and it doesn't have equal to, so it's definitely a dashed line. Remember, I told you it'd be a vertical line, so a line where x is greater than negative 3, it's vertical. The numbers, and again, greater than, dash line, doesn't have equal to. And then if it is greater than, like this one, you can't shade above or below this, so I can use this to remind you if it's a vertical line, the numbers that are greater than are on the right, so we'd shade right. If it would have said less than, those numbers that are less than are on the left. So I want to shade where all the numbers that are greater than negative 3, so again, that would be to the right. Okay, so everything to the right, so not down here, don't shade over here because the only one line is pointing there. I guess we could extend this arrow a little bit to show that the region we should be shading is over here, where it's, you know, these lines would both cross here, and everything here, right, should be what I'm shading. So, like I said, I like to use arrows to show me where to shade, and then only shade the region where both lines are pointing at the end of the problem. If you do just shade both, you just got to make sure you darken in the one region where they overlap. But either way, you know, get y by itself, graph both lines, be careful if the line's vertical or horizontal, be careful whether the line should be solid or dashed, right? And that's all in the notes. What type of line it is, whether to shade above or below. You can find that in the 4.6 notes, and then also in these notes.